Epinephrine. Epinephrine, a hormone secreted by the medulla of the adrenal glands. Tyrosine is created from phenylalanine by hydroxylation by phenylalanine hydroxylase. It is also ingested directly from dietary protein. Catecholamine-secreting cells use several reactions to convert tyrosine serially to L-DOPA and then to dopamine. Depending on the cell type, dopamine may be further converted to norepinephrine or even further converted to epinephrine. The sympathomedullary pathway involves the stimulation of the medulla by impulses from the hypothalamus via neurons from the thoracic spinal cord. The medulla is stimulated to secrete the amine hormones epinephrine and norepinephrine, responding to stress. Strong emotions such as fear or anger cause it to be released into the bloodstream. The reaction, fight-or-flight response, prepares the body for strenuous activity. In medicine, it is used chiefly as a stimulant in cardiac arrest, as a vasoconstrictor in shock, and as a bronchodilator and antispasmodic in bronchial asthma. The adrenergic receptors, adrenoceptors, are a class of G-protein-coupled receptors that are targets of many catecholamines like norepinephrine and epinephrine, which will generally stimulate the sympathetic nervous system, SNS. It may cause an increase in heart rate, muscle strength, blood pressure, and sugar metabolism. It is a non-selective agonist of all adrenergic receptors, including the major subtypes alpha-1, alpha-2, beta-1, beta-2, and beta-3. Binding to these receptors triggers a number of metabolic changes. Binding to alpha-adrenergic receptors inhibits insulin secretion by the pancreas, stimulates glycogenolysis in the liver and muscle, and stimulates glycolysis and inhibits insulin-mediated glycogenesis in muscle. Binding to beta-adrenergic receptor triggers glucagon secretion in the pancreas, increased adrenocorticotropic hormone ACTH secretion by the pituitary gland, and increased lipolysis by adipose tissue. Together, these effects lead to increased blood glucose and fatty acids, providing substrates for energy production within cells throughout the body. Its actions are to increase peripheral resistance via alpha-1 receptor-dependent vasoconstriction and to increase cardiac output, increasing heart rate and contractility via its binding to beta-1 receptors. It causes a prompt increase in blood glucose concentration in the post-absorptive state. This effect is mediated by a transient increase in hepatic glucose production and an inhibition of glucose disposal by insulin-dependent tissues.